and we want to have a clear migration path for SysML v1 users and tool implementers. So that's what we're trying to accomplish. This is all relative to SysML v1. We feel like we are making great, significant strides over what we had with v1. Next slide. So the essential elements of SysML v2, the first thing is we basically started over. SysML v1 was based on and we made an early decision to start with green sheet, if you will, a new meta model for SysML v2. But at the same time, we we preserved much of the UML modeling capabilities that were there, but we're focused on system modeling. This meta model is grounded in formal semantics from the beginning of kind of a first order logic, declarative semantics. And it's very, is going to really help with the precision of the language and the ability to, for example, reason about the model. We've also have much more robust visualizations. We've introduced a very flexible view and viewpoint mechanism. And we have not only the graphical views similar to what we had in SysML v1, and tabular views, which we also had in v1. But as you'll see, we have a textual syntax that complements the graphical syntax. I'll share that with you in just a moment. And then the third essential element is the standardized API. So this is what's really key to improving the interoperability with other engineering models and tools. So these three elements, a new meta model, more robust visualizations, and a standardized API, I would say, are sort of the key elements of v2. Next slide. So if you look at the basic capabilities at this level, they're kind of similar to SysML v1. If you look one layer down, you'll start to see a lot of the differences. But you see, for example, the structure. You see, bear with me a sec here. You see the ability to decompose your system, to interconnect the parts, to classify your component, your parts, and etc. Which we had in v1. And behavioral capabilities, both function-based or equivalent of activity diagrams, state-based, sequence-based, and use cases, again, look similar to v1. We have requirements like we had in v1. Requirements in v2 have the additional potential to be more precisely defined using constraint expressions. I'll show a simple example of that a little bit later. Whereas in v1 we had what we called parametrics. Those of you familiar with v1 know about parametrics. In v2 we have analysis cases. I think we'll find this to be a bit more straightforward to use when integrating with other analysis tools. And SysML v2 also includes an expression language. So you can specify, everything, forms of equations. We're not trying to be a MATLAB Simulink by any means, but we have a lot of capability to express, for example, logical expressions and the like. We have verification cases. SysML v1 had test cases. The verification cases are quite a bit more robust than what we had in v1. And as I mentioned before, we have the view and viewpoint mechanism, which we had in v1, but is quite a bit more robust in v2. So I'll just try and give you some highlights and kind of highlight some of you'll start to see what some of the differences are and as well some of the similarities with v1. So if you, in this next slide, what I'm showing here is what you in v1 would be called a block. And in v2, we call it a part definition, or part def for short. And it's a vehicle. And so the vehicle is a part def. And it has a series of features that include various attributes, includes various ports, actions that the vehicle performs, in this case only one, and the vehicle states. So those are all defined. You can define other what we call features of vehicle that aren't shown here, but this is just a typical common set of features that you might define. And if you look at the attributes, in the attributes, you start to see some of the differences right off the bat. You can see, for example, we have dry mass is a kind of ISQ colon mass. So what that means is we have a library called International System of Quantities. We had something similar in V1 called we referred to it as QUDV. This is a much improved and much more robust and easier to use extensive library. It captures all the standard units that you would get in the ISO standard metrology standards, sorry. And so instead of each person having to define their own mass, they can say a mass for this vehicle, in this case, a cargo mass or a fuel mass or a dry mass, whatever it might be. And we're going to make it a kind of mass from the library. And when you do that, you can automatically give it units, and it understands what kind of a quantity it is, and you can give it any units and values in a very, very straightforward way. In V1, I'll just kind of mention this. In V1, you had to define a different value type for every different type of unit. Here, you just say it's a mass, and if you're in kilograms or you're in pounds mass, you don't have to do another value type, and you can give it a value, and it's robust enough that if the tools support it, they'll be able to do the dimensional analysis. So if I'm expressing it in 1 unit and I change the value, I change the unit, it would know to change the value corresponding to the unit conversion. Things like that. The other thing you see for the mass at the top there, you see also it's a kind of ISQ mass, a mass from the International System of Quantities library, but it's equal to the dry mass plus the cargo mass plus the fuel mass. This an example, very simple example of an expression that's using the SysML v2 expression language. It's obviously trivial, but it gets quite sophisticated. There's a lot of ability to express many different kinds of both logical and quantitative expressions in V2. So let's go on to the next slide. And what you're looking at here is what you saw in the previous slide was the graphical syntax. And what you're seeing here is the corresponding textual syntax. And which is pretty apparent, is it's really basically just a different rendering of the same underlying model. So you can see it's a part def vehicle. You see the attributes there, such as the mass and dry mass and fuel mass, etc. The ports there on that were in the ports compartment on the previous slide, the action and the states. So all of these, basically the bottom line is that the textual syntax is just a different rendering from the graphical. They both represent the same underlying model. So if you're in a SysML v2 tool, we anticipate that tool vendors will support both the graphical and textual syntax, that you would have different panes, and you're free to use the graphical view or the textual or any combination that's. We found the textual syntax has really helped us in terms of making this language much more precise. It's just unambiguous. And I think for those of you who've used SysML v1, you find a lot of areas that can be ambiguous. You just won't find that in v2, or let's put it this way, much more difficult to find that in v2. And that in part is attributed to the fact that we developed this textual syntax for the language. Going on to the, before going to the next slide, I want to just go back one. At the last item there, it says exhibit states, vehicle states, parallel, and then you see 2 curly brackets with some, couple asterisks in between. So if you were to, in the tool here, you were to expand that, you would see the states would be, you would get further breakdown of the vehicle states. But here you just see a single line. What I'll show you on the next slide is what the vehicle states look like graphically. No surprise, it looks like what you might be familiar with in SysML v1 with some significant differences. And so let's go to that. And this is corresponding graphical representation for the vehicle states. You see things like the keyword parallel there at the top. Oops, bear with me. With my technology limitations, I'm trying to look at this also on a separate app, see if I can follow along. But at any rate, you see the keyword parallel. So what that means is that for vehicle states, that its child states are parallel, or if you will, concurrent. So in this case, you see operating states and health states, and those are both concurrent states, meaning you will be in one of those states at any given point in time in both an operating state and a health state. But you don't see the keyword parallel in the operating states or health states. So those are mutually exclusive states, sequential, they go by different terms. And so you can see here, you go from the off state to the on state. And on the transition, you see an expression there, and that is using the SysML v2 expression language, where it says the ignition command is on equals on, and you'll transition from off to on. And then you get in the on state, you see the entry, the do, and the exit actions. If you're familiar with V1, you understand that. And you see a constraint. And in this case, it says electrical power is less than or equal to 500 watts. So this is an example. If you went back to, if you referred back to the vehicle part def, you would see we defined power as a kind of power from the ISQ library. And so all we had to do was put in watts, a value and the units, and it totally understands that. So you just enter 500 and whatever units are appropriate, and the language will understand that. And so basically, it's a simpler state machine. These states, unlike in SysML v1, we don't have reach. We just have states that decompose into other states. So vehicle states decomposes into operating states and health states. Operating states decompose into off states and on states, etc. So it's just a straight decomposition. It's simpler than and it really you find it just generally that makes it much easier to use and to work with. Let's go to the next slide, and we'll see the corresponding textual syntax by, if you will, we saw the states vehicle parallel under the part def vehicle, but if you took those curly brackets and you opened them up, this is what you'd see. There's more to it than what's shown here. It doesn't fit on one slide, but you can see that you have the parallel there, and then you see the operating states. You see the off and on state. You see on entry, you perform self-test. When you enter the on state, you provide power as the do behavior. On exit, you apply the parking brake. You see the constraint. The electrical power is less than or equal to 500 watts. The point is, it's, again, you can see the equivalence as just a different rendering from the graphical syntax. You also see the transitions defined, transition off to on, transition on to off. You can see that expression that you accept an ignition command, and if the command is in a equals, then you make the transition from off to on. So it's fairly straightforward, fairly intuitive. We think the learning curve should be more lower than what we had in V1 by quite a bit. This is fairly straightforward. Going on to the next slide. So I've just given you a bit of an introduction to just sort of the basic, starting basic elements of SysML v2, just looking at a part def and looking at the behavior of that part def. And what I want to emphasize now is just note this, the reuse patterns that we use within SysML v2. And in v1, we use the term definition and usage as more or less informally as a pattern, but it was not applied consistently throughout the language. So we would treat, for example, a part property, we would talk about as a usage of a block. And the block was the definition element, and the part property was the usage element. In v2, definition and usage are actually built into the meta model at the root level. So they're very, very foundational. And so what a definition element is it basically defines an element, such as a part def, like I showed for a vehicle. And a usage then is you define it once, but multiple usages of the definition, which we talked about in v1. But here, there's a very important distinction that I'll bring out in a moment about usages in v2 versus v1. But as part of a reuse, you define something once as a definition element, and then you can use it as many times as you want. One of the important distinctions is that this pattern, because it's applied at the root of the language, it's applied consistently to all language concepts. So whether it's part or actions or requirements or constraints or analysis cases or whatever it is, they all follow the same pattern. So once you learn of this basic pattern and sort of the power of it, you learn it in effect one time, you can apply it across the entire language. And it's fairly straightforward. It's basically got these concepts of specialization and redefinition and subsetting. There's just a few terms that you learn, and they all provide this reuse capability, powerful reuse capability. And I'll show just an example of that in the follow-on slide. The next concept or reuse pattern is variability. And we've just introduced a very small number of concepts. We had some discussions very early on when we were developing the requirements for v2 to say what variability concepts do we want to bring in. And we agreed on the first concept was a variation point, where a variation point represents something that can vary. So for example, I have an example in a couple slides later where I talk about it can be a 4-cylinder engine or a 6-cylinder engine. So the engine is the variation point, but so can the cylinder diameter vary. So the cylinder diameter is also a variation point. You can have a small diameter cylinder or a large diameter cylinder, or with specific values if you choose. So the key thing here is, so we've got the variation point is the element that varies, and then the variant are your choices at a variation point. So in the case, again, with the engine is the variation point, a 4-cylinder engine is a variant, and a 6-cylinder engine is a variant. So those are your options or your choices at the variation point. Once again, like with definition and usage, these concepts are applied consistently across the language. So not only can parts vary, attributes vary, states vary, actions vary, requirements vary, anything can be a variation point and can have variance. So it's quite nice and quite powerful. The other core concept that was already part of the language but applies here as well is a variability constraint. And what this means is if you select a variant at one variation point, that in turn may constrain your selection at another variation point. So you pick something at this variation point, you pick the 4-cylinder engine, and you'll see in the example that constrains what choices you have, for example, for your transmission, or vice versa. So that's a variability constraint. So we have that as a second really important reuse pattern that's built in more or less at the foundation level. So just to follow up on the part, on the definition and usage pattern, what you see here is a part def or part definition, the same one we talked about before for the vehicle. And if you go to the next animation there and just click there, you'll see that we have a part that is a usage of that definition element. And it's called a vehicle _1, lowercase v for and on vehicle. And a very important distinction here between V1 and V2 is that the usage, in this case, lowercase v vehicle 1, basically inherits the features from the definition. So all of those features you saw in the definition are inherited by the usage. And you say, well, why do you? Because you inherit the features, and then you can either override those features with more specialized features, or you can add new features, in the same way that you can specialize, if you will, blocks. But what this allows you to do is each usage can be adapted to its context. So you have a much more capable, much increased capability to design configurations in a more straightforward way. So you have a definition that's, say, very highly reusable. You create a usage, and this usage is a little bit different than that usage, so you can modify it. There are some methodological choices that are available to you here. I have been adopting an approach which we called from early on a usage-focused modeling approach. And in that methodology, again, you're not restricted to this, but the way I'm using the language, this pattern, is I treat the definition as a black box specification, and I treat the usage as a design that conforms to that specification. So the specification at the black box level actually doesn't contain any internal structure. It's just a specification of black box characteristics. And then I inherit those by the usage, if you will, and then I add my parts and my internal structure to the part, as opposed to the part definition. So this allows me to have vehicle 1 as one design configuration that conforms to, if you will, the vehicle black box spec, but I can have another vehicle 2 that conforms to that same specification with different structure. So it provides a lot of flexibility, and we're finding it to be quite useful and quite just natural. So I suspect this is how people will be modeling with it, but that ultimately will individuals to define. What you see on the left, first of all, note that the vehicle is a part def, vehicle with capital V, and the usage, or vehicle 1, is a part. So you have part and part def. And I'll show you a few slides from now that terminology is used consistently throughout the language. So you'll see, for example, action and action def in a similar way. So everything follows this, same pattern of inheriting the features and allowing you to hide. So what you see in the, for example, is you see the inherited features have the little caret next to them. So for example, mass is just inherited from the vehicle, but and so is fuel mass, etc. But you see dry mass has that other little symbol there, which is a symbol for redefines. And all that means is it overrides the inherited feature from vehicle. So whereas in vehicle you had dry mass was just a kind of ISQ mass, it's all you said about it. In vehicle 1, mass is equal to the sum of the part masses. So you overrode the original definition of dry mass to be more constrained with the sum of the part masses. And in addition, you can see down below there's a couple of parts that have been added, which weren't in the vehicle part def, but are in the vehicle part. and you can see there's an engine and a transmission. So it just gives you the sense of this pattern again applies consistently across the entire language. If you go to the next slide, you'll see the corresponding textual syntax for this. And again, it's quite, it's pretty straightforward. You see vehicle 1 : vehicle. That means the vehicle 1 usage is defined by vehicle. You can see the attributes. You see the keyword redefines. You can either use that little symbol, or you can use the keyword redefines. I think I have a mix throughout here, just mixing it up a little bit. You can see that there's the added part there for engine and transmission, and you can see engine is further characterized by its mass, some ports, action, it generates torque, and it has a part which are cylinders, and there are 6 of them. And similarly, you can see it has a part transmission. And at the last statement, there is a connect statement where you connect the drive power to the drive power port on the transmission. So that's a connect statement, if you will. And I'll show you that connection 2 slides from now. But let's first go to the next slide, and we'll just see the decomposition of vehicle 1 into engine and transmission. So if you go to that one, the next slide.
Okay, that one. Okay.
Yes, you can see the decomposition, and the thing that's worth noting here is you'll notice we're decomposing parts. In V1, you are not able to decompose parts. What you have a block that has part properties. Those part properties are typed by other blocks, and those blocks are, have part properties, etc. So when you go down a decomposition tree, you have to sort of step ladder your way down from usage to definition to usage to definition. Here, we're literally just decomposing the parts. In fact, I won't elaborate on this right now, but you don't even have to have a definition. There's a default definition that the language provides you. So if you wanted to, you could literally just say, well, here's vehicle 1, and it's got an engine and a transmission, and the engine has 6 cylinders. And you can just create a parts tree. So it's very, very natural. Once again, that pattern applies to everything: actions, states, requirements, you name it. They all follow this exact. On the next slide, you'll see the parts interconnected. So this is, no new, this is just graphical rendering of the same information you've already seen in the textual syntax. You see the engine connected to the transmission there. And you can see that the drive power port on the engine is connected to the drive power port on the transmission. Notice that just like in V1, the drive power port on the transmission, its definition is conjugated, meaning it reverses the direction of all the directors. So whatever outputs on one are become inputs on the other. That's just a convenience. And there's some other things that are worth noting on here. Somewhat different than V1, but it's generally pretty intuitive. You're just connecting your parts. There are some things I think I'll come back to them rather than trying to cover them here just because of time. If you go to the next slide, I've shown just an example of a requirement. If you go to the next slide, yeah. And a requirement in SysML v2 is basically a kind of constraint that a valid design must satisfy. So that's what a requirement is. It's a kind of constraint that you're imposing on your solution space. And in order to have a valid design, that design must satisfy that constraint. So what you see here, if you go to there, you'll see just a few features of this requirement. Let's show it. So the first one is an identifier. Should be able to see that. It's got an identifier with just one. And by the way, you can put an identifier like that any element. It's not limited to requirements, so it applies generally. So everything can have an identifier if you so choose. It has a shall statement, your typical, text shall statement, and then it has a constraint expression, which basically shows that the actual mass must be less than or equal to the required mass. And you can see those properties are actually defined, they're actually inherited from their definition. But that's why they have, one has a caret next to it, and the other one overrides it by giving the required mass a particular value. So the required mass on the definition doesn't have a value, it's left generic because a mass requirement is very reusable. So you don't want to give it a value. But here we just overrode the generic mass required with a specific value of whatever that says, 1,650 kilograms. In addition, a requirement in this example you can see has an assumed constraint that the mass fluid has to, pardon me, I'm having to look at my slides myself on this end, and it's hard to read at times. That the mass of the fluid is less than or equal to 40 kilograms. So we just made that assumption. So in order to satisfy this requirement, it is assumed that the assumptions are true. And given that the assumptions are true, then you must have a mass actual that's less than the mass required. There are other features of requirements. This just gives a simple example, and I would expect methodologically that often you'll typical shall statements, but for selected requirements, you may choose to specify them in a more formal way, such that they can be analyzed and verified through analysis. And in order to do that, you need this more formal application. The required value is, and of course, this is a very simple constraint expression, but in SysML v2, you can actually express very complex constraint expressions, logically, logical ands and ors, and more complex quantitative aspects to it. So you can really go to town with these, and you may do that on selected requirements. So that's a little bit about some of the, just given the amount of time, I'm just touching on a couple of the aspects of the language. I want to mention this fact that SysML v2, I mentioned up front, is grounded in formal semantics. And as part of that, there is this underlying 4D model, and where entities like a part have a lifetime. And there's associated with that lifetime, you can establish a reference clock. You can override that clock, so you can give it quantitative time across that lifetime. And in addition, you can divvy up the lifetime of any entity into what are called time slices, which are, as the name implies, kind of portions of time, or snapshots, which are instances of time. So you can take the lifetime of an entity and you can talk about any portion of its lifetime, either as a time slice or as a snapshot or some combination. It's 4D in the sense that not only has this sort of built-in temporal logic or temporal semantic, but it also has spatial semantics, which are actually quite extensive. And so a spatial entity has a spatial extent. And for example, there's coordinate frames that an entity has, so you can talk about positioning it within a coordinate frame. You can talk about its shape, and SysML v2 has an extensive shape library. Now, the goal of SysML v2 is not to be a CAD model, clearly, but it allows specify geometry at a level that's appropriate for this kind of modeling. So for example, if you had a keep out zone, or you had a physical envelope, or what have you, you could specify that. But it does have quite sophisticated semantics, such that if you want to integrate it with more, like CAD models, that you have the ability to define, to express that. So it even has the topological operators of intersection, union, and differencing. So it's quite nice. There's also the concept of individuals. So in SysML v1, we have instances. In SysML v2, we have individuals, which basically are uniquely identifiable entities, if you will, from a class of entities. And that individual will, again, have a lifetime, and you can talk about that particular individual, like your car, over its lifetime, and you can talk about different periods of its lifetime, and you can talk about points in time across its lifetime, those snapshots. So this concept of individuals and lifetimes is really quite nice and much more intuitive and straightforward, really, than what we have with, for example, instance specifications in SysML v1, which it's hard to differentiate an instance that represents a unique individual from an instance that is a point in time. Those two concepts are not clearly separated in SysML v1, but they are in SysML v2. So to kind of wrap up on the language, let me see, how is my time, Graham? How am I doing?
About 5 minutes, but we can go into a bit of it. It'll just be cutting into our break. We have
okay, about 5 minutes more.
Basically, so you can talk for another 10 minutes. So
okay, that should be about right. Okay, so just briefly, I've emphasized this already, but if you contrast v2 and v1, the thing I'm showing here is just from a terminology perspective, you can see the correspondence, and this is partial. It's not all the concepts, just some of them. But you can see in v1 we have part property and block. In v2 we have part and part def. And then you see things like in v1 you have proxy port and interface block. In v2 you just have port and port def. You have action and activity in v1. You have action and action def in v2. So the terminology is completely regular in v2. They always says X and X def, where X is the kind of element it is. And again, the pattern is completely consistent. What you can do with parts, you can do with actions or ports or what have you. So it's just really nice and regular. Going to the next slide. So let's kind of leave that. I've got one kind of summary slide about comparing v2 and v1 in coming up in a moment. Just real briefly, the API, I wanted to say a few words about it. The idea here is that those blue boxes, rectangles at the top, are external applications. They could be virtually anything. And the idea is that the SysML model is stored in some kind of repository and using some technology. And the standardized API is the green thing. And that allows you to access the model, the SysML v2 data, if you will, in a standardized way. This is really key to enhancing interoperability. And the different green rectangles there just show how tool vendors can use different technologies to implement the same standard interface. So I'll just kind of leave it at that, and let's go to the next slide. And just as an example, what you see here is you see the SysML v2 model in the center, being stored, and you see the API around it. So you access this model, and in this case, you see there's a CAD view that's accessing the model. We talked about the geometry briefly. This was an actual geometric model of a quadcopter that was made, and it was just using a simple open source CAD viewer to access it. And if you click again, you'll see another if you hit it again, Graham, yeah, and just the second one on the right below there is a analysis model that accesses the equations from the SysML v2 model and then solves them. And this is using, in this particular example, it's based on a Maple, which is pretty extensive math solver. And then in the lower left there, you see graph visualization. That's basically Tom Sawyer. It's hard to read and see, but it's a pretty sophisticated graph visualization tool. Again, it uses the API to access the data and then render it in a graph. And then the upper one is actually Intercax's Sandia, basically accessing the model and doing version model management with it. So these are just some examples of the kinds of things that we would expect to integrate the SysML v2 model with other tools and applications. Going on to the next slide. So let's see if so just real quickly, again, in the interest of time, I'll just highlight at the top level here. If you really compare to, we set out with a set of objectives and, things like usability with the goal of making it simpler to learn and use. And we think there are several aspects of this that do make it simpler to learn and use, even though it's a very sophisticated language and there will be a learning curve. I think people should be able to get up and start being productive. We think it's definitely more precise. Hopefully you can start to see that from even the simple examples I shared, the formal semantic grounding, the textual syntax, and it's more expressive in a variety of ways. So if you just click through, just go through the whole set. So I just said it's more precise. I'm now talking about more expressive, just continue. In a variety of ways. I only had a chance to touch on a few aspects of it, but there's many aspects of this just make it much more expressive, more extensible. We have a really nice way to extend the language and customize it, and more interoperable with the API. Again, I didn't have a chance to discuss each aspect shown here, but these are some of the ways in which we feel we really have worked to address the objectives that we set out to. Just real briefly on the next slide, we said one of those objectives, the last one I showed, was to make sure we have a transition path for SysML v1 users and tool implementers. And so we are developing standardized transformation from v1 to v2, such that if you have a conformant SysML v1 model, you can transform it to a SysML v2 model. I'll leave it at that. Next slide. So the milestones, we've had our last submission in November of 2021. It was our second revised submission. We're now in a few weeks, we will be submitting our third revised submission, and then we'll finish up with our final submission in the first quarter of 2023. If you go to the next, just hit bullets there. So we'll wrap this thing up, and if adopted in the first, following our submission in the first quarter of 2023, if it's adopted, it becomes a beta specification, and that means it's really pretty stable. We're just basically taking feedback from tool vendors and usability issues and trying to work through those over the next period of time, make some refinements to the language, and then go out with a final adopted spec in 2024. So there are tool vendors out there right now working on implementation. So we're getting the feedback. We have been for some time. And so let's just summarize on the next slide. So as I said, you can, just go to the whole thing. SysML v2 is addressing a lot of the limitations that we had encountered with v1. We think it has the potential to really improve both adoption and effectiveness of MBSE in the ways that we talked about: the precision, the regularity, the interoperability, etc. The approach I highlighted, those use the new meta model with the formal semantic, the flexible graphical and textual notation. There's a lot that can be done graphically. We are not constrained to the typical 9 diagrams. It's a big graph, and there's some really sophisticated to do with that, and we are going to encourage that with the vendors. Standardized API, as we talked about, and the transformation spec from V1 to V2. So those were some of the elements. And we'll get this beta spec out hopefully first quarter of next year, or just following the first quarter. And then a year later or so have the adopted spec, hopefully with tools. So that's kind of our timeline. The last slide I have, and the next one, is just noting that, and again, you can proceed ahead with the animation there, is that we have been following an incremental release process to develop SysML, pretty agile kind of process. And we have a monthly release repository with the specs are there. The pilot implementation is there where you can actually use the language. And there's a URL down there where you can actually sign up if you're interested. There's some training material. So it's a pretty good repository for those of you who are interested, want to learn more. And with that, I think just go to that last slide. Go to the next slide and open it up. Whatever time you allocated or we have left, I'm happy to take any questions and do my best to answer them.
Any questions from anyone? So we've got some people.
In the chat as well.
Yeah. So there's someone coming up on the screen with the universe behind them. Do you want to ask a question, and then we'll take Stephen's question?
It's Stefan.
Hi, Steph.
So basically you define an element and then you use a defined element in a specific context. I was wondering where that context is captured. So in your example, you had the defined element was vehicle, and vehicle in specific context was vehicle 1.
Yeah.
I was wondering how you can associate that with a specific context.
Right. So typically, you would basically define a context part, and you would say, for example, context, and then under it you would have vehicle and road and driver and passenger and all that stuff. So you'd put all those elements under a context part. But what's done in SysML v2, if you don't do that, there is a default context that's provided, and it's basically this thing called anything. So you're basically part of this most general. Think of it as you're by default, you're part of the universe. I don't want to start sounding philosophical, but that's what happens in effect in the language. You're part of the most general thing, and that's the way it happens. But when you're using it, you'll typically, you may define vehicle over here as a usage, but then you want to put that usage in a particular context with a particular road, with drivers, with whatever, so you just define that context and pull that part into it. But again, if you don't, it automatically by default has this most general context.
Okay, thank you very much.
You bet.
So we've got another question from from our room at the moment. Tim Rabbit.
Yeah, Tim Rabbit. First of all, thanks very much, Sandy, for a very informative presentation. 2 quick questions. You mentioned the ISQ special measurement of attributes. And can you also measure attributes like integrity or adaptability that don't conform with such an ISQ specification? So that's the first question. And the second question was,
could I answer that one first?
Yeah, sure.
Okay, and then the second one. So as far as attribute, so you can define an attribute. You're not constrained to use the library. That's just offered up to you. So that's the first thing. So we also obviously have primitive data types of all kinds. So you can use your standard primitive data types. You know, if you want to just say it's a real, it's adaptability, and you don't want to give it any units. But the other thing you can do is you can, you know, you can clearly create your own units. So where you're not restricted to this library. So for example, currency is not in the ISQ. So we should probably add to our library a currency because those are just so common. But you know, you're not constrained to just what's in the library. You can define your own. Furthermore, you can take units and you can mathematically combine them. So if you had, just say for the heck of it, you wanted to say, in fact, I have one for fuel economy as, you know, a mass per distance, or you know, or volume per distance of fuel, volume of fuel per distance, or whatever it is. And you can just combine them. So we've got volume and we've got distance. So you can say volume per distance is my units for fuel economy. So you can do things like that, which is really neat, really powerful. Does that answer the question?
Yes, thank you.
Okay,
and the second question is related to requirements engineering. Do you support notions of different requirements at different stages, such as stakeholder requirements, system requirements, derived requirements, concessions on requirements?
Yes, we do. I think, you know, what are sort of some terms. For example, we have built-in derived requirement. But if I go back to your kind of opening question there, do we support requirements at different stages? So if you tell me more explicitly what you mean, for example, there's versioning of requirements, which is requirements at different stages, but I don't think that's what you mean. There's different levels of detail derived requirements that evolve over time. That we clearly support. So we can version them, we can derive them, we can do all kinds of things with requirements. I guess I'd have to understand a little bit more to really understand what is meant by your question.
Yeah, so I was thinking in terms of the 29148 notions of things like stakeholder requirement sets and system requirement sets. So you can have multiple sets of requirements in your systems engineering process.
Mm-hmm. Yeah, I mean, we don't have those built in per se, but those would be pretty straightforward to define and standardize for your project or your organization, or if we decided it was relevant for a broader group, you know, across industry, we could build a library of those kind of requirements and classify them. So it should be no problem to create different kinds of, for example, requirement sets. That's very straightforward.
Thank you.
Okay.
So we have a question got another couple of questions on the chat, and then one more question in the room. So we've got Stephen Powley next.
Oh, hi. Yeah. Thanks for a great presentation and all the work that you and the team have put into it. I think it's
Thanks, Stephen.
An enormous job, and well done. It's a fairly fundamental question, so please tell me to shut up if it's too crazy. But I've been working a lot on semantics and I work with vocabularies, and one of the problems that I've found is that the way that an element is defined in UML, and this is carried over to SysML v2, is that the name string is an inseparable attribute. So I can't take that out of the class or the block and deal with it as an entity in its own right. And so I wondered why that element, every element has to have an ordered string fixed to it, rather than having the base type as an unnamed element and then adding a name to the base type if it needs a name.
So the unique identifier is its what's the universal UUID.
UID
That-
for the good.
The element, the only thing that's really uniquely identifies the element is the UUID.
Yeah.
And that's not even visible to the user. I mean, that's the tool more or less manages that.
Understood.
And there's a whole sophisticated ability for naming. So yeah, you have, and this is defined at sort of really at the foundation level for every element. You have names, and you have short names. You have aliases. So the names and the short names are associated with the element. But the only the thing that doesn't change across the lifetime is its UUID. And you also have names that are dependent on its namespace, which basically are the aliases can be given for different namespaces.
Yeah.
So there's a lot of flexibility than what we had. Probably the best way to get real answers to that, and I don't have them at my fingertips, but is to review the specification itself and look at the foundation spec, which is called kernel. And in there, at the very beginning, you'll see the description of elements and ID names, and it's quite a lot of thought was given to that. So we did not go with the UML approach to naming.
I've got that.
Okay.
I'm looking at figure 4 elements in particular.
Figure 4 elements. Figure 4 in the spec.
Yeah, in 83211.
Oh, okay. That level of question is probably, we'd have to take it outside of here. That's probably and
that's an edge question.
Realistically, I'd probably need help Ed Seidowitz, who's the language architect, and he could give you a much more sophisticated answer than I could ever give. But I'd be happy to connect you with it if you want to get at an answer to that.
That'd be
and
fantastic.
To understand
Thank
the
you.
rationale. Just send me the note and I'll pass it along.
Okay.
So thank you very much, Steve. So next question comes from Julian.
Sorry, from who?
Yeah, Julian Johnson. Hi, Sandy. Julian Johnson here.
Oh, Julian.
We met many years ago, as you'll recall, in the early stages of SysML.
Yeah, I'm still. Your voice.
Yeah, I'm still alive and kicking. Thanks also very much for your very informative presentation and all the hard work you're doing. I've got a simple question, which is a reference back to your book, The Practical Guide to SysML. When is that likely to be updated to support V2?
So I'm not going to update that book because this really, you have to think of SysML V2 as a new language. I mean, it builds on V1, but it's really, there's so much that's foundation, been re-engineered that I don't think you can get there by just doing an update. So Ed and I are planning to write a book and undertake that endeavor once we get past the submission, the final submission, and that'll take us clearly that's a big endeavor. So I don't know how long it's going to take.
Excellent.
But that's our plan.
Excellent. Okay, that's great. Thanks very much, Sandy. Cheers.
Thanks, Julian. So
good hearing your voice, Julian.
Cheers, Sandy.
Okay.
Another question from the room, this time from Ralph Haynes. I think you wanted to ask a question, Ralph.
I was going to leave it, but I will ask it. Variation modelling, one of my favourite topics. There are generally two types. There's one that's modal, such as 6 cylinders or 4 cylinders, and then there's one that might be a range or a large number of discrete values. So, for example, the diameter of a cylinder. Does it cover both?
Well, the range of values, meaning, so it only includes discrete options.
Okay.
So you have to define your variants as discrete options. So now, having said that, one of the options could have a value range associated with it, but if that's what you're getting at, like if you had a parameter of let's say mass, and you were looking at a range of mass from 1 to you know, a range of mass values, then you wouldn't deal with that using the variability concept per se. There are ways to deal with it, but not using the variation concept directly. Is that what you had in mind?
I think it was like having a predefined list of variants, but I think the way that you're suggesting doing this, Sandy, is to have a set of parts that actually reflect each of the different, like 2, 4, 6, 8.
It's very hard to do if you have, say, numbers between 1 and 100. But maybe this will be a dev rec for SysML 2.1.
Yeah,
exactly. You know, we tried to take on a base capability to get started, and we had some of the folks who've been very actively involved in that community participate in the approach, and they were pretty pleased. I mean, people, I don't know if you know Charlie Kruger. You know him? He's got
Charlie Kruger, Big Lever.
Big Lever. Yep. So we had him. We had PTC folks involved. We had a whole range of participants with expertise, and they seemed to be satisfied. They have to speak for themselves, but they seem to be satisfied that we came up with a reasonable starting point. But I absolutely agree that over time we'll probably evolve this capability.
I can't see the question.
Ian is next.
Yeah. So thank you very much. There's a question from Ian Hobson next. And I think after that, Adam will take some of the ones from the chat for you. So Ian.
Hello there. Hi, Sandy. It's nice to hear a voice against the book.
Good to hear you as well. Thanks.
But I have a bit of a sort of perennial problem with sort of lots of standards and committees and that kind of thing. Because I'm a safety engineer. Is that when they all link together? So we've obviously just had RAML sort of released in its true form, the risk analysis and assessment modeling language.
Yeah.
How are you linking what you're doing in V2 out to the other language? I mean, for me especially, it's the RAML language. I'm really interested about how that link comes through. You know, what's the timeline for taking what you've been doing and sort of drawing that back through the other languages that are sort of based off SysML? So
that's going to be a question for the other standards groups to ultimately answer. But we've had initial discussions, like for example with UAF folks and others, and I believe there is, and we've had discussions with OMG, including at the last OMG meeting with their kind of some of the leaders there. And, you know, first we want to get this thing approved and out there and working, and, you know, kind of validate that it's working as expected. So, you know, we got a couple of years in front to get to that point. There's nothing to preclude the other standards from initiating an effort to basically, if you will, rehost their standard if it's based on SysML, or even if, and we've had some discussions, and we think there's some fairly straightforward ways to begin to, in effect, move your specs. Like for example with RAML, we've actually did an early early prototype just to see what would it start to look like if we moved RAML over to SysML v2. And it was just a very cursory effort, but it looks pretty straightforward. It just doesn't look that hard. So I think the question is, once the vendors have a v2 implementation, we have this extension mechanism that's quite nice. We expect that these standards can kind of, in effect, rehost if they're based on SysML v1, they could be based on SysML v2 in a fairly straightforward way. But ultimately, that decision is up to the standards. But just in Ramel's case, you know, they have that basic underlying concept of a situation, and everything sort of a specialization on top of that. And we took a look at that, and we feel like we can handle that really nicely. And we have the cause-effect concept in SysML, you know, what have you, that I think is consistent with Ramel. So I think I mean, that's my best shot at an answer. But we'll have to look to the different standards group. It's really entirely up to them.
Thanks for that, Sandy.
You bet.
So there's a couple of questions, written questions in the chat. The first was from Philip Jackman. It's about the rollout. So has there been any engagement with any training organisations for the rollout of SysML v2? I see a high demand for both conversion courses and or SysML v2 courses, or is it being left down to the tool vendors?
So, I mean, for starters, what we are trying to do is provide some standard training material right up front. So Ed has developed a training material for the textual syntax. It's pretty good and you know, fairly complete and completely consistent. I've been working on sort of the corresponding training material with the graphical syntax. So between those two, those are basically up on that site that I mentioned. So we have a really good start to just having that. I've seen a lot of folks already, you know, some as members of the team, of the mission team, and others that are not, that have been already kind of looking to develop training material. I haven't had detailed discussions with anybody on what they're doing. I mean, we just had our hands full, but I think there's a lot of interest, if you will, in people developing training material around it. I think we're going to have to learn how to use it. I mean, there's sort of, you know, it will impact methodology. And I think you have really some new capabilities that you want to leverage in SysML v2 that we didn't have in v1 that will affect methodology. So it's not just the language and it's not just the tools, it's going to be methodology. And I think there's a lot of room for some really interesting and frankly exciting stuff around methodology that will have to, you know, evolve. So I think, you know, the initial training should be fairly straightforward, just the language training and the tool training. Hopefully that'll be straightforward. It's just, here it is. And we've got a what I consider to be a pretty good start on that right now. But, or at least the language part, you know, and the tool vendors will clearly provide the tool vendor training. Sorry for a long, kind of clumsy answer, but.
Yeah, there's one question from Lawrence, then I think Matthew, is it Matthew?
Yeah.
Had his hand up, and then I think.
Well, yeah, I think we've only got time for 3 more questions, so we'll make Tom the last question. Yeah.
There's one from Lawrence. In SysML v2, as we model out requirements, is it still possible to link to UML use cases and actors to show mapping between personas, use cases, and requirements?
Between a mapping between what? Could you repeat that again? Between what?
I don't know if Lawrence wants to elaborate on what I read out. But,
hello. So doing some requirements engineering here. We're building out the different layers of requirements, and inevitably we're using use case diagrams and actors, building out personas to show. And I'm just wondering on the ability to still link up to those artifacts like we are doing at the moment. Does that still make sense in this new paradigm?
It does. You can still, you can replicate that in v2.
Good, thank you.
You bet.
Okay, so yeah, so the last question from virtual meeting. So Matthew, would you like to ask a question, please?
Yeah. Hi, Sandy. Just wanted to check, does SysML v2 include the definition of like diagrams like v1 does?
Yeah, we refer to them as views, and we've got, and it's consistent with our, you know, what the view concept is in SysML v2. What we're doing is we're defining a set of standard views. Actually sounds like a UAF, but we've got, instead of referring to them as standard diagrams, they're standard views. And basically what a view is in SysML v2 is it's a, basically you take your model and you filter it and you select what aspect of the model that you want to, what the content that you want to see. So the first part is basically that filter or query, if you will. And then the second part is how you render the information. So the view concept includes both the filtering concept and the rendering method. And we have standard diagrams or standard views, if you will, that we're predefining and we're asking the tool vendors to support. So we're making those what we call normative. We're asking tool vendors definitely provide this, and it gives you this sort of base capability. But we're in no way limiting tools or users to the standard views. In fact, we encourage views that go well beyond what the standard views are, that meet the needs of your state. So you want to see certain content as long as it's consistent with the underlying meta model, the abstract syntax, and we've got some formal specification of the graphical syntax called BNF, graphical BNF. As long as it's consistent with that sort of underlying aspect of the language, then you can present that data in a variety of ways. So I'm really hoping we see some really nice tool innovations to present data in interesting ways, present this model information in interesting ways. A simple example is like 3D graph visualizations, where you can just see things in more interesting ways. And they wouldn't be, as I said, they would not be limited to the standard views. But standard views gives us at least a starting point for people to share this information.
Matthew, it might be worth pointing out that one of the reasons behind this is it's much, much closer to things like ISO 42010, which is architectural descriptions, isn't it?
It is.
But that basically sort of sets up a whole viewpoint aspect type thing, and that's going through a redesign at the moment or being redone. But it's very interesting because these are some of the ideas that we had from UAF as well, and it's really great to see this being propagated through into SysML. So, last question. Sorry, Sandy?
No, definitely. And, the view and viewpoint concept have been, I think, greatly improved over what we had in V1.
Yeah.
Consistent. The UAF folks have looked at it. I think they feel it's totally consistent with what they're doing.
Yeah, I agree. Last question from Tom.
Hi there, Tom Westbury, Animal Dynamics. I've got a question about extending the language and domain-specific languages. Is it possible to create relationships, new meta types within the language with the same sort of rigor that the existing relationships exist within the standard? So can I create strong definitions that would, then have checking abilities within the tool and things like that?
Yes. So there's kind of a lot to the answer. And again, this probably, to get a more sophisticated answer, I'd probably have to draw upon Ed, but
yeah, I was going to say that's an Ed answer.
Yeah, but briefly, so you have the meta model, and the language architecture is, you've got this meta model. It's quite regular. It's layered. Starts with element and relationship, builds up to some called the core concepts, which include things and like classifier and feature and generalization and things like that. All this, and then there's another layer called the kernel modeling, the kernel, and those layers are all in this foundation spec. It's called the kernel modeling language. Then you have SysML v2 it extends that. So this first kernel is really the foundation where all the formal semantics are first introduced, all that stuff. And then we build SysML v2 on top of it, and there's this meta model. But when you extend the language, you basically can do the extensions through the model library. And I need more time and other slides to illustrate this. But the bottom line is you're basically extending concepts that are defined in a library. So all of the meta model concepts are in effect instantiated in the library. And then you go further extend by extending the library. And when you do that, you're building on the foundational semantics of the language. So if you build new relationships, if you extend existing relationships, and of course we have very general relationships like the equivalent of associations, we call them connection, whatever. But we have of those concepts in SysML v2. You can create them, but you're going to get the basic semantics when you extend it. So as long as you use the standard extension mechanism, you're going to retain the semantics and be able to do checking on that and all the rigor you're asking about.
But basically, it goes beyond like stereotype. Like in UML and SysML, we had stereotype extensions, but this is actually using the language to define itself and to continue and extend that language.
Thank you, Graham. Very well
First
said.
elements, yeah.
That's
Exactly it.
good to hear. Thank you.
Yeah.
Right, I think that's it for now. I really appreciate your time, Sandy, especially taking questions for half an hour afterwards as well.
My pleasure.
And really good talk. Thank you very much for doing this. Really appreciate it. There's a few people clapping on the screen as well.
Yeah. No, thanks for the opportunity to present. Yep. If you have follow-up questions or you want to, engage in this further, you can reach out to me, and I can, if you have tough questions that I can't answer, I can get you answers, stuff like that.
Yeah.
All right. Well, thank you, and I'll hang up now.
Okay. Cheers. Thank you very much, Sandy.
You bet. Bye now.
Thank you. Bye. Okay. So that went on for a lot longer than I expected, but that was really good. I thought it was good interaction. Brilliant. Going to have a 10-minute break. Come back at 5:30. We can have a chat between ourselves if you want about SysML2, or we can just have a roundup and a summary of finalisation. But I think 10-minute break is all in order now. I think everyone could do with a cuppa or a restroom break. So come back at 3:30.
Problem with the first-class extension mechanism is the opposite problem to the normal one we have. It gives you all the power you want to your elbow, but what will happen is people will go with